All right. Hi, guys. I am sorry I'm not there today. I had some family matters that came up. So I'll be back on Wednesday. So please check your homework here on the video and take the notes. And if you have any questions, we'll talk about those in class on Wednesday. If I go too fast on the scrolling here, just pause the video and double check your work. Make sure you got the correct answers. All right, so today we're going to be talking about secant and cosecant, which remember they're reciprocals to sine and cosine. So they're kind of related, and we're going to see how those graphs are different than the sine and the cosine. So first we're going to look at the cosecant graph, and you can see I've placed the values in the chart over there to the right. Remember, cosecant is going to be the reciprocal of sine, so those y values. And whenever the y value is 0, we're going to have that undefined, which means we're going to have asymptotes. So we're going to have asymptotes at 0 and pi and at 2 pi. So I'm just going to draw those into my graph first. They're going to be here in blue. So I know there's asymptotes there. Okay, and then I'm going to split my pi for my one rotation here. Pi over 2 is in the middle, and then we have our 3 unit circle values on either side. Okay, and then I'm going to bring my bar up here to 2, because we actually do have a value that goes to 2. So at pi over 6, we start at 2, so I'm going to put a dot there. And then at pi over 6, we're at 1.4, which is just below halfway. And at pi over 3, at 1.15, so right above, and then at pi over 2, we have our value of 1. And then, again, next to pi over 2, we have another pi over 3, so it's going to go up to 1.15, and then to 1.41, because that's 3 pi over 4, and then at 5 pi over 6, we're going to be at 2 again. And it's going to make this parabola shape. And it will go on forever, never touching the asymptotes. Just keep going up. Okay. And before I draw in the other pieces, I want to draw in the sine function just there from to pi. So I'm going to do that in green. So at 0, remember, sine is 0. And then at pi over 2, sine is 1. And at pi, it's back at 0. Notice that the peak of the sine is actually the vertex point there for our cosecant function. Okay? Now, after pi, right, if we were to split our function up, this would be 3 pi over 2. We have our 3 lines in the middle. Okay? Those are going to become negative values, right? Because sine is now negative in quadrants 3 and 4. So we're going to take the values we had up here, and we're going to just flip them down to the bottom. So I'm going to draw a negative 2 down in here. Okay, and we're going to start at negative 2, and then go to negative 1.4, negative 1.15, and negative 1. And then it's going to come back. And again, we have our loop there. Okay. And notice it just flipped over the x-axis there. And if I were to continue drawing my sine function in, sine at 3 pi over 2 is negative 1, and sine at 2 pi is 0. So notice both of our vertexes start at where our graph for our sine function turns. Okay? And then the asymptotes are always at where sine touches 0. Okay, so let's look at an example of just the cosecant, and then we will okay, so we need to draw in the secant one. So let me just add that in a sec. Okay, so the secant value there was we're going to graph as well. I like to first think of what the cosine graph would normally look like and then base my secant graph off of that. If you recall back to the cosecant graph, right, the sine was wherever so wherever the sine turned, we had our parabola's vertex. The same thing happens with secant. So I'm going to graph the cosine function in blue. So cosine at 0 is going to be 1. So I'm going to use this line as my 1. Okay. So there's my 1. And then at pi over 2, it's 0. And then at pi, it's negative 1. And then at 3 pi over 2, it's 0. And then at 2 pi, it's back at 1. Please remember that there's always 5 major points that we're talking about when we're graphing all of these functions. So there's our cosine, right? And it would go on like that. Just as cosecant, wherever sine was 0, right, we had those asymptotes. Remember? So the same thing is going to happen with the secant. So we're going to have asymptotes. I'm just going to use the highlighter for the asymptotes. I'm going to have an asymptote wherever there's a 0. So there's a 0 there, and there's a 0 at 3 pi over 2. Okay, so both of those are asymptotes, and I don't have any values there for the secant graph. So for my green, for my secant, okay, notice that the cosine graph is peaking here at 1, right, on the far y-axis. So that means the graph there will be going upwards, okay? And then we have another peak here at pi, but it's downwards. So if it's in the lower hemisphere, it's going to go the U-shaped down, okay? And then again at 2 pi, it's peaking upwards again. So our U would go like that if we were extending on to 2 pi. Now, when you'll see me graph it, for the most part, I only graph to where I need to. So I only need to the 2 pi, so I don't need that right piece there. And if I'm over here at the 0, I'm going from 0 inwards to pi over 2, so I don't need the stuff to the left of 0 because my point that I'm starting at is 0. Okay, so the green is our graph of our cosecant. I mean, of our secant. I'm sorry, I said cosecant, of our secant. So let's look at it with some amplitudes and period changes. Okay, so here all we have that's changing from our graph is the period. Okay, I mean the amplitude. Sorry, the period would be next to the theta. So we have an amplitude of 4. So 1, 2, 3, 4. -1, -2, -3, and -4. Okay, and we're doing cosecant, which is opposite of our sine function. So I know that I'm going to have asymptotes at 0, because that is where sine is 0. I'm going to have one at pi and one at 2 pi, again, because that is where sine is 0. I honestly suggest just recalling either the sine and cosine graph and what that looks like, and remembering that the parabolas open at the bottom or the top of their vertexes, or just memorizing the pattern of the u's. So if we're looking at cosecant, all we've changed is the amplitude, which means our u will no longer, if I add in my pi over 2 and my 3 pi over 2, our u will no longer start at, the vertex will be at 1, the vertex is going to now be at 4. And our vertex was on that pi over 2, and that'll be a u that goes upwards. Now, if there had been a negative in front of the 4, we would just flip this over the x-axis, and it would be at -4, and it would be going downwards. Okay, at 3 pi over 2 was the next place that we had a vertex, and that was normally on -1. And if I just shift it down 4, I'll be at -4, and my graph will go downwards. Okay, and there was no period shifts there, right? We had our amplitude of 4, our b is a 1, because there's nothing next to our theta there, so that makes our period 2 pi. Okay, so that would just be our graph there for cosecant of theta. Okay, for y equals secant 2 theta, now we don't have an amplitude shift. Our amplitude is still 1. Our b now is 2, which means our period is going to be 2 pi divided by our b, so 2 pi divided by 2, or just pi. So now we have actually shrunk our graph, so there's going to be more graphs happening. So our full period will only come to pi here. And so we're going to have it happening twice. So I'm going to split everything up. So if I have a pi, then I have my, right, I normally have pi over 2 and 3 pi over 2. But now this period has gotten smaller, and it's going to go through the full cycle from pi. So there's going to be middle ones in between there. Okay, our normal secant graph has a value at the start, but then the next value is going to be an asymptote. So I'm going to have my asymptote at that pi over 4, okay? And then there's a value, and then there's an asymptote, and then there's going to be some sort of value, and I need to fill in my other ones. Miss Brown forgot to put them in. Okay, so then I have 2 there. So I'll have a value on pi, and then I'll have my asymptote, and I'll have a value on 3 pi over 2, and then I'll have an asymptote, and I'll have a value on 2 pi. Okay, now the normal cosine graph will start on 1. So here we're going to have our value on 1, and we just need the part of the graph that comes in to the direction we're going there. So it'll be an upward faced arrow. And then at pi over 2, okay, we'll have that value at -1 and our parabola going downwards. At pi, we have that upwards parabola starting at 1, because again, we don't have an amplitude. 3 pi over 2, we're going to be at -1. And at 2 pi, we'll be at +1 again, and it'll be coming inwards towards the graph. Okay, and that's how it changes for a period shift there. Notice that we now not only have one period happening, we actually have 2. Okay, Now here, notice that we do have that negative in front. So if we have a negative in front, it just means we have to flip our usual graph. So there's that negative. Our amplitude is 2, so I know I'm going up and down 2. So 2 and negative 2. My b is 2, so my period is 2 pi divided by b. Again, my period is going to be pi. So I'm going to split my normal ones up, put in my pi over 2 and my 3 pi over 2. And then I'm going to split those again. And those values are pi over 4 and 3 pi over 4, 5 pi over 4, and 7 pi over 4, if you need those in there. Okay, and we're doing the cosecant, which is opposite of sine. So sine starts with an asymptote because it has that value of 0. So I'm going to draw in my asymptote there at 0. It skips, so there'd be a value there, and then we have an asymptote. Then we have a value and an asymptote. Value, asymptote, value, asymptote. Okay, now the sine graph normally will go up to the value of 1. Okay, now if we're flipping over the x-axis, that means it would be at the negative 1. And now the amplitude is 2, so we would have a value there at negative 2. And normally the graph will open upwards, but since we flipped over the x-axis, it will open down. Okay, and then again, we just follow that pattern. If it was opening down there, it's going to open up at the next one. And then it'll open down at our next place, which is 5 pi over 4, and then at 7 pi over 4, it's going to be opening upwards. Okay. And our last example that we're going to do together is 3 secant theta divided by 2. So our A here is 3. Our B is 1/2. So our period is 2 pi divided by 1/2. Now remember, if we're dividing by a fraction, it's like multiplying by the reciprocal. So it's like multiplying by 2 over 1. So our period now is 4 pi. Notice on here, I only actually go till 2 pi. So we're actually just splitting it in half. If you have your own graph, you can just do pi, 2 pi, 3 pi, 4 pi if you'd like. But I'm just going to show you what happens if you split it down in 2. So normally we would have 5 points, but our points would be pi, 2 pi, 3 pi, and 4 pi. I'm just going to graph the 3 sections that I already have here on the board. So we're doing secant, right? And secant is the reciprocal of cosine, and cosine normally has a value on the y-axis there. So if I'm going up 3 and down 3, it would have a value at 3. And then at the next section, it would have an asymptote, which this next section would be pi, because our period is 4 pi. Okay? The way to figure out how many or what the values on the x-axis here would be is to divide that number that you get for your period by 4, and you'd get pi. So that means your intervals is pi. Okay? So here we'd have pi and 2 pi and 3 pi and 4 pi. So pi and then 2 pi would have a value down here at negative. So my graph for just the 2 pi would look like this. If you continued it out, it would make the full graphs wider. I'm going to show you the intervals for the previous problems. So here, if our period was pi If you divide it by 4, you get pi over 4 being your interval. So notice it goes pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. Same thing would happen here. Divide pi, you get the pi over 4 family, and so on. Please try the next 2 examples here on your own, and I will check those when I come back to class. So I'll give you some time here to solve this one. And go ahead and just pause the video and solve. Okay, and please try 3 cosecant of pi theta over 4 as well. Please be careful when finding the period. Remember, you're going to flip the fraction and then multiply across. And again, we'll talk about this when I get back. So take the time to go ahead and pause the video here and solve for this function. All right, for the remainder of class, you should have picked up a packet when you walked in or been handed a packet. Please complete this thoroughly. I am going to grade it for accuracy. Please use your notes and take your time. I only put a few new problems on there. The rest should be review or practice from what we've either done with sine and cosine or looking back at the unit circle and unit circle values. I hope you guys have a good rest of your day. And please remember to turn in that packet at the end of class. And if you don't finish it, it's homework, and I will be taking it when I get back on Wednesday.